SUNIL sir, good morning.
Good morning.
Morning, sir.
Bilal sir, good morning.
Good morning, sir. Good morning. Good morning.
Good morning, sir.
Good morning. Good morning.
Yes, sir. Shall we start now? Hello, Mira sir.
Good morning to all. Respected Sunil MATHEW sir, Head of the Department Science sir, respected teachers, dear participants. Today we have the first day of our Explore the Infinity program. We ask our respected Reverend Father John J. Chavala to welcome our guest Sunil MATHEW sir.
So very good morning to one and all. നമ്മുടെ ഇന്നത്തെ പ്രോഗ്രാമിന് മുഖ്യ അതിഥിയായിട്ട് റിസോഴ്സ് പേഴ്സൺ ആയിട്ട് എത്തിയിരിക്കുന്ന ബഹുമാനപ്പെട്ട സുനിൽ മാത്യു സാർ, SB കോളേജ് മാത്തമാറ്റിക്സ് ഡിപ്പാർട്ട്മെന്റിന്റെ തലവൻ ഡോക്ടർ ഷൈൻ സി മാത്യു സാർ, ബഹുമാനിരായ മറ്റ് അധ്യാപകരെ, മാതാപിതാക്കളെ, പ്രിയമുള്ള വിദ്യാർത്ഥി സുഹൃത്തുക്കളെ. ചാൾസ് കാലം കോൾട്ടന്റെ പ്രസിദ്ധമായ ഒരു ഉദ്ധരണി ഇങ്ങനെയാണ്: കോളേജിലാണ് സാറിന്റെ PG പഠനം പൂർത്തിയാക്കിയത്. അതിനുശേഷം കാലിക്കട്ട് NIT-യിൽ നിന്ന് തന്നെയാണ് സാറിന്റെ ഗവേഷണ ബിരുദം, PhD ബിരുദം. ഇപ്പോൾ പിന്നീട് അവിടെ അധ്യാപകനായിട്ട് ജോയിൻ ചെയ്തു. അവിടെ ഇപ്പോൾ ഒരു റിസർച്ച് ഗൈഡുമായിട്ട് സാറ് സേവനം ചെയ്യുകയാണ്. നമ്മുടെ ഡിപ്പാർട്ട്മെന്റിലെ ബഹുമാനപ്പെട്ട സോണി സാറ്, ഡോക്ടർ ആന്റണി മാത്യു സാറ് ദേവഗിരിയിൽ പഠിപ്പിച്ചിരുന്ന കാലത്ത് സുനിൽ സാറിനെ പഠിപ്പിച്ചിട്ടുണ്ട്. സാറിന്റെ ഒരു ഗുരുവായിരുന്നു. സാറിനെ കുറിച്ച് പറഞ്ഞാൽ ഗണിത ശാസ്ത്രത്തെ കുറിച്ച് അറിവുള്ളവര് ഒത്തിരി പേരുണ്ട്. എന്നാൽ അറിയാവുന്ന കാര്യങ്ങൾ മറ്റുള്ളവർക്ക് മനസ്സിലാകുന്ന രീതിയിൽ അവതരിപ്പിക്കുവാൻ സാധിക്കുന്നവരുടെ എണ്ണം വളരെ വിരളം. ഒരേ സമയം ഗണിതശാസ്ത്രത്തിൽ അറിവുണ്ടായിരിക്കുകയും അതേസമയം അത് രസകരമായ രീതിയിൽ, ആസ്വാദ്യകരമായ രീതിയിൽ അവതരിപ്പിക്കുകയും ചെയ്യാൻ കഴിവുള്ള ഒരു വ്യക്തി. അതാണ് സുനിൽ സാറിന്റെ പ്രത്യേകത. തീർച്ചയായിട്ടും ഏതാനും വർഷങ്ങൾക്ക് മുൻപ് +1 +2 കുട്ടികൾക്കായിട്ട് SP കോളേജ് മാത്സ് ടാലന്റ് സെർച്ച് നടത്തിയ അവസരത്തിൽ ഞാൻ ഇന്നും ഓർക്കുന്നു, സുനിൽ സാർ ഇവിടെ വരികയും കുട്ടികൾക്ക് വളരെ രസകരമായ രീതിയിൽ ക്ലാസ് എടുക്കുകയും ക്ലാസ്സിന് ശേഷം കുട്ടികളൊക്കെ സാറിന് ഇങ്ങനെ പൊതിഞ്ഞു തന്നാണ് സംശയങ്ങളും കാര്യങ്ങളും ഒക്കെ ചോദിച്ചുകൊണ്ടിരുന്നത്. അത്രയ്ക്ക് രസകരമായിട്ട് വിഷയത്തെ അവതരിപ്പിക്കുവാൻ കഴിവുള്ള ഒരു വ്യക്തിയാണ് സുനിൽ സാറ്. സ്നേഹമുള്ള സുനിൽ സാറെ, ഏറ്റവും സ്നേഹത്തോടെ സാറിനെ ഈ പ്രോഗ്രാമിലേക്ക് സ്വാഗതം ചെയ്യുന്നു. ഒപ്പം ഈ പ്രോഗ്രാമിന് എത്തിച്ചേർന്നിരിക്കുന്ന മാതാപിതാക്കളുണ്ട്, കുട്ടികളുണ്ട്. നല്ല ഒരു സെഷൻ എല്ലാവർക്കും ആശംസിച്ചുകൊണ്ട് ഈ ഒരു മീറ്റിംഗിൽ ഇപ്പോൾ ആയിരിക്കുന്ന എല്ലാ അധ്യാപകരെയും മാതാപിതാക്കളെയും വിദ്യാർത്ഥികളെയും ഒറ്റ വാക്കിൽ സ്വാഗതം ചെയ്തുകൊണ്ട് ഞാൻ എന്റെ വാക്കുകൾ നിർത്തുന്നു. നന്ദി.
Now I welcome our Sunil sir to deliver the lecture.
Good morning to everyone. Good morning. ഒന്ന് രണ്ട് പേര് ക്യാമറ അല്ല മറ്റേ മൈക്ക് ഓൺ ആക്കി തിരിച്ച് ഗുഡ് മോർണിംഗ് പറയൂ. ഗുഡ് മോർണിംഗ്. യെസ്, മതി നിങ്ങളുടെ മൈക്ക് ഓഫ് ആയി. എനിവേ, നിങ്ങളുടെ കോളേജിലേക്ക് ഇതുപോലെ ഒരു അവസരം ഓൺലൈനായി തന്നതിന് ഫസ്റ്റ് ഓഫ് ഓൾ ഐ ലൈക്ക് ടു താങ്ക് ദ അതോറിറ്റീസ് ഓഫ് യുവർ ഇൻസ്റ്റിറ്റ്യൂട്ട്. ഇത് രണ്ടാമത്തെ തവണയാണ് നിങ്ങളുടെ ഇൻസ്റ്റിറ്റ്യൂട്ടിൽ ഞാൻ വരുന്നതും. പണ്ട് ഓഫ്ലൈനായിട്ട് വന്നു, ഇപ്പോൾ ഓൺലൈനായിട്ട് വന്നു എന്നുള്ള വ്യത്യാസമേ ഉള്ളൂ. എനിവേ, എനിക്ക് ചെറിയ കുട്ടികളോട് സംസാരിക്കാനാണ് പൊതുവെ താല്പര്യം. തീരെ ചെറുതല്ല, നിങ്ങളുടെ പ്രായത്തിലുള്ള കുട്ടികൾ. എനിക്ക് നേരിട്ട് നിങ്ങളുടെ കണ്ണുകളിലേക്ക് നോക്കി സംസാരിക്കാനാണ് എനിക്ക് കൂടുതൽ ഇഷ്ടം. ഇതിൽ മലയാളം അറിയാത്ത ആരെങ്കിലും ഉണ്ടോ? ഇസ് ദെയർ എനിബഡി ഇൻ ദ ഓഡിയൻസ് who cannot understand Malayalam? I hope no. Okay. So anyway, what I was trying to tell you is, I like to speak to your eyes. നിങ്ങളൊരു ക്ലാസ്സിൽ പോയിരിക്കുമ്പോൾ ടീച്ചറുടെ വായിൽ നിന്നും വരുന്ന ആ ഒരു ഇൻഫർമേഷൻ എന്ന് പറയുന്ന സാധനം നമ്മളുടെ ശരീരത്തിലേക്ക് വരുന്നത് പല വഴികളിലൂടെയാണ്. അതിലൊരു വഴി കണ്ണാണ്, ഒരു വഴി കൈയാണ്, അല്ലെങ്കിൽ നമ്മുടെ പഞ്ചേന്ദ്രിയങ്ങളാണ്. ഈ പഞ്ചേന്ദ്രിയങ്ങൾ ഇങ്ങനെ അബ്സോർബ് ചെയ്യും നമ്മുടെ കണക്കും മറ്റ് ശാസ്ത്രങ്ങളും എല്ലാം. അപ്പോൾ നിങ്ങളുടെ കണ്ണുകളിലൂടെയാണ് എനിക്ക് അകത്തേക്ക് എത്താൻ കഴിയുക. ഇപ്പോൾ നിങ്ങളുടെ കണ്ണ് കാണാത്തത് കൊണ്ട് കൂടുതലും എനിക്ക് നിങ്ങളുടെ ചെവികൾ ഉപയോഗിക്കേണ്ടി വരുന്നു. നിങ്ങളുടെ ചെവികളിലൂടെ മാത്രമാണ് ഇപ്പോൾ എനിക്ക് നിങ്ങളിലേക്ക് ഇൻഫർമേഷൻ തരാനായിട്ട് കഴിയുന്നത്. അത് വലിയ ഡ്രോബാക്കാണ്. ചെവിക്ക് അതിൻ്റെതായ കുറേ ഡ്രോബാക്സ് ഉണ്ട്. ചെവി എന്ന് പറയുന്ന ഒരു പ്യുവർലി മാത്തമാറ്റിക്കൽ ഇൻസ്ട്രുമെന്റുമാണ്. അതിനെപ്പറ്റി ഞാൻ പിന്നീട് പറയാം. അപ്പോൾ നിങ്ങളുടെ മറ്റിന്ദ്രിയങ്ങളെല്ലാം ഈ ചെവിക്ക് വേണ്ടി സപ്പോർട്ടീവായിട്ട് വെക്കണം. നിങ്ങൾ വേറെ ആക്ടിവിറ്റീസിലൊന്നും ഇടപെടാൻ പാടില്ല. നിങ്ങൾ വളരെ പണ്ട് വലിയ ഗുരുക്കന്മാരും ധ്യാന ഗുരുക്കന്മാരും ഒക്കെ ധ്യാനിക്കുന്ന ഒരു പോസ്ചർ നിങ്ങൾ കണ്ടിട്ടുണ്ടാവും. ബുദ്ധനൊക്കെ മടിയിൽ ഇങ്ങനെ കൈ വച്ചിരിക്കുന്ന ഒരു പോസ്ചർ. അപ്പോൾ നോളജ് എന്ന് പറയുന്ന സാധനം നമ്മൾ ഐഡിയയും BSNL ഒക്കെ നിങ്ങളിലേക്ക് വരുന്നില്ലേ? നമ്മളുടെ മൊബൈലിലേക്ക് നമ്മളറിയാതെ ഒഴുകി വരുന്നത് പോലെ ഈ നോളജും നിങ്ങളിലേക്ക് കടന്നുകൂടും. ഒരു കടന്നൽക്കൂടിന്റെ ചെറിയൊരു ദ്വാരത്തിലൂടെ തേനീച്ചകത്തേക്ക് കയറുന്നത് കണ്ടില്ലേ? അതുപോലെ ഒരു സ്ട്രീം ഓഫ് ഇൻഫർമേഷൻ നിങ്ങളുടെ ചെവിയിലൂടെ കയറി അത് നിങ്ങളുടെ അകത്തൊരു കൂട് കെട്ടി ഒരു ഹണി ബീ കോമ്പ് പോലെ അങ്ങനെ നിൽക്കും. അപ്പോൾ നമുക്കറിയാം there is a limitation for listening capacity. അല്ലേ? No one can sit with 100% listening for more than 1 hour. അത് എത്ര നല്ല തമാശ പറഞ്ഞ ഒരു ടോക്ക് ആണെങ്കിൽ കൂടി നിങ്ങൾക്കറിയാം ഒരു പരിധിക്ക് അപ്പുറം ഇരിക്കാൻ പറ്റില്ല. സ്റ്റിൽ വി വിൽ ട്രൈ. നിങ്ങൾ എല്ലാവരും ഇന്നത്തെ ദിവസം ഇപ്പോൾ ഇത് എത്ര മണി വരെയാണ് നമ്മൾക്ക് ആരെങ്കിലും ഒന്ന് പറഞ്ഞാൽ എനിക്ക് അതനുസരിച്ച് ഒന്ന് ജസ്റ്റ് അറേഞ്ച് ചെയ്യാനാണ്. എത്ര സമയത്തേക്ക് എനിക്ക് പോകാൻ കഴിയും? ടീച്ചേഴ്സ് ആരെങ്കിലും ഉണ്ടോ?
സാറേ 1 മണി വരെ.
ഓക്കെ, ഓൾറെഡി 11:15. ഓക്കെ, നോ പ്രോബ്ലം. അപ്പൊ നമുക്ക് കുറെ കഥകളും കാര്യങ്ങളും പറയാനുണ്ട്. ഓക്കെ, ഇനി എനിക്ക് ഒരു കാര്യം കൂടി അറിയാനുള്ളത് ദ അനാട്ടമി ഓഫ് ദ ഓഡിയൻസ് ആണ്. ഞാൻ സാധാരണ ഒരു ടോക്കിന്റെ ടോപ്പിക് തീരുമാനിക്കുന്നത് അവിടെ ചെന്നതിന് ശേഷമാണ്. എൻ്റെ കമ്പ്യൂട്ടറിൽ കുറേ അധികം ടോപ്പിക്കുകൾ ഇങ്ങനെ PPT-കളായിട്ട് വെച്ചിട്ടുണ്ട്. സോ ഐ ഡിസൈഡ് മൈ ടോപ്പിക് ഓൺലി വെൻ ഐ റീച്ച് മൈ ഡെസ്റ്റിനേഷൻ, മൈ ഓഡിയൻസ്. അപ്പോൾ ഇവിടെ വാട്ട് ഐ അണ്ടർസ്റ്റാൻഡ് ഈസ് many of you have passed your +2 and you are about to join for your B.Sc, right? Someone please answer to me. Am I correct?
+1 സ്റ്റുഡന്റ് ഉണ്ട് സർ.
+1 ഉണ്ട്. അത് ധൈര്യമായിട്ട് പറഞ്ഞോളൂ. വാട്ട് ഈസ് റോങ് വിത്ത് ദാറ്റ്? അപ്പൊ നമ്മൾ കുറച്ചും കൂടെ തമാശയാവും. ഞാൻ പറഞ്ഞില്ലേ, ഒരു ഓഡിയൻസ് മുമ്പിൽ ഇരിക്കുമ്പോൾ നമുക്ക് അവരുടെ അടുത്ത് പോയി ചോദിച്ച് അവർക്ക് വേണ്ടുന്ന സാധനങ്ങൾ, സാർ കുഡ് യു സ്പീക്ക് ഇൻ ഇംഗ്ലീഷ്? യെസ് ഷുവർ. അഭിഷേക് കുമാർ, ഓ ദാറ്റ്സ് വൈ I asked you in the very beginning. All right, that is why I asked you in the very beginning about your capacities about Malayalam language. All right, so today's language will be English. I'll go as slow as possible. Okay, right. So this should be an interactive session. I don't like a one-side lecture. Okay, someone can interact to me without opening your video. You can just unmute and interact. There is no problem, because I'll be in trouble after 10-20 minutes. I will be in utter trouble, because if there is no response, I will die without energy. Energy is the most important thing, as you know. What about my voice? Is it clear to everybody?
Yes sir.
All right, that is even board. What I want is, I want just to have some formal talk to you. Okay, so don't think that many missiles will come over your head, mathematical equations, and you will get bored in time. No, nothing of that sort will happen. But there can be conflict of interest among us sometimes. Some of you may not like that style sometimes, not always. Sometimes you may have tendency to generally. So where should we begin? Where should we begin? And okay, I don't know. I think I can use little Malayalam also, because there can be parents also, right? Yes. So sometimes in the middle I may use a little bit of Malayalam also. You don't worry about it. I will translate it to English. So my question is, where to begin? Okay. What about you? Are you all interested in movies? I couldn't see anybody. Arya M. Nair, what do you say about that? Arya, are you interested in movies?
Yes, sir. I'm interested.
Yeah, anyway, don't switch off your mic. What type of movies you watch?
I like horror movies, comedy
Hollywood
movies.
movies or Malayalam movies? English or Malayalam? Maybe Malayalam, right? Come on.
I like both.
Oh, good. Anyway, you don't like thrillers, fiction type of things? Have you seen these movies like, Nolan's movies? Nolan is a very famous director in Hollywood, you know that, isn't it? Christopher Nolan, any idea? No. Who among this audience can tell me about Christopher Nolan? Gobu, you know something about him. Gobu, please unmute and tell me some of his movies' names.
Sir, Inception, Interstellar, The Prestige.
All right. Anyway, you are good in that. Oh, director Batman, very good. I am really, really interested in movies. So I started with movies, that's so. You said Interstellar. I will start with Interstellar then. Okay. In Interstellar, what is the, thread? What is the thread? Anyway, if you have interest in movies, interest in maths, interest in physics, you may have to watch these Nolan's movies. What about Interstellar? What is the theme or thread of that movie? Can someone tell me? I'll take pauses in the middle because I have to save my throat also. So I will keep quiet for a little time. You have to speak during that time. Gobu, you know the theme of that?
It's a futuristic world where Earth is no longer habitable. So
Exactly.
they have to find another planet or else the species would go extinct.
Absolutely. And
That's
do
what
you believe that such a situation will happen?
I don't see why it's not possible, but I can't really say. Maybe not.
But Gobu, you know that, and let me ask you some simple questions. In what speed Earth is spinning on its own axis? Any idea? Any idea is welcome.
Not. I can't really remember actually.
Nearly 10,000 kilometers per second.
Okay.
Earth is, I have picture of Earth, I think. Let me see. Okay, I think I will share my entire screen. What about my screen? Is it visible? Yes, you can see my screen, right?
Yes, sir.
Good. Yes, let us begin with this Earth. Anyway, don't worry about the topic title written over there, Mathematics of Nature 2. Don't worry. It is not our topic at all for the time being. Just look at this image of Earth. How beautiful it is, right? Yeah. And it, in its own axis, it's being rotated at 10,000 kilometers per second. My question is, what will happen if it reduces its speed by 5,000 kilometers per hour? Someone please tell me. Hello? Hello? You can hear me, no? Hello?
Yes, sir. Yes, sir.
Answer to my question.
Day will be 24 hours and night will be 24 hours.
Exactly. So one day will be 48 hours. Am I right?
Yes, sir.
Exactly. What we call a day is simply a mixture of light and darkness. So when it comes, the one half of Earth will be facing sun, but its speed is very less. So it will take 24 hours to cover that particular portion. Then it will go to the other side. So nights and days are stretched. Suppose it goes further and further. Suppose it goes further down and Earth is now rotating at its own axis at a speed of only 100 meters per second. Can you imagine that situation? Someone please join with me, otherwise I'll become bored. Can you imagine that situation? If you are not getting any points, you may just ask me, I will tell you once again. Someone tell me what will happen on that stage. Can you guess? Same thing. Hello? Hello? Someone tell me what will happen?
Light will disappear.
Yeah, told me about that Nolan's movies? Gobo. Who actually told me about Nolan's movies first? I've already told you everybody must be here. Don't go anywhere. Then there won't be any meaning at all. You should be here for 2 hours. Gobu.
Yes, sir. I did. I told you.
Yeah, you came back. Very good. So in that stage, when Earth is rotated at a speed of, say, 100 meters per second, Earth will become inhabitable. Am I right?
Yes.
Why? Because, it is like Sahara Desert. You will never find the other end of it. If you start walking from one point, see, days will be stretched to hours. Maybe about, suppose, you think about situation where there is no night for 100 days. So what will happen? You will be simply ash in moments. Suppose there is no sunlight coming to Earth in, say, about 180 days. It will be very, 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 temperature will be negative. And everything will become frozen. And no plants will survive. No human beings will eat water because there won't be any more water. So, frankly speaking, it is estimated by NASA that the spin of this Earth, that particular period, is coming down every day. Okay? Little by little. Not by a huge amount, but that speed is coming down. So one day, that day may come sometimes 1 million years, after 1 million years. We cannot predict anything, but there are some other devilish type of creatures to come before that. Earth will not exist in 1,000 years. That's what I believe. I have plenty of reasons for that. Don't worry about it. This is one reason. In, say, about 2,000 or 20,000 or 40,000 years, the spin of Earth will be very, very feeble, and you cannot expect any night as well as days, and it will be. And one more thing, and another interesting thing, oceans are spread over the surface of the Earth. They are intact because there is a reasonable speed in which Earth is going on. You take a bucket full of water, you just take a thread and just attach to bucket. Just try to rotate the bucket as you do with a stone. Whatever is inside the bucket will never go out of that bucket unless you reduce your speed. If there is a constant speed, your water will be inside your bucket. But when you come down with regard to speed, the water will come out of that, right? And may fall on your head. Such a scenario also will be there. So these oceans will be getting dislocated. If the speed is coming down, this particular ocean, the distribution of ocean will be irregular. Oceans will become lands, Lands will
Morning,
become
sir.
ocean. Yes. You have something to ask me? Hello? Hello? No. Fine. And there is one more, actually, anyway, we will skip from this particular topic very soon. And that day is coming. Anyway, that's what I want to tell you. That day is coming where this earth is no more habitable. And what is your idea about outside this earth? What is outside? I mean, or before that, let me ask you a very simple question. You may be sitting in a room, fine? Just look around you. Just look around you. What do you see there? Can someone react to my question? You are just looking around. What are you seeing around? Anybody? Did you understand my question?
The nature itself, sir. I think
I am asking you,
What
what is, huh?
the nature. We are seeing the nature.
But what is nature? No, I'm not asking about, you are not looking outside window. You may be inside a room. You are not seeing any furnitures, but what else you are seeing? Suppose there is no furniture at all.
We're seeing the four corners. I think four corners.
Anyway, you should be microscopic in observations. The coordinates, they are all geometric things we have constructed. I'm asking about, suppose, I'm talking about something else. Hypothetically, I'm asking you about the object which are not visible in front of your eyes. Can you see everything in front of your eyes?
No, sir. We can't see it because there are so much subatomic particles like immunes, like is boson, like there are so much subatomic particles are there, and we can't see with our naked eyes. Even we can't see ultraviolet or infrared in our eyes. So if we are stuck in a room, there are so much particles around us, air, humidity, or every part. So there are so much particles. So
What is your name? Is it Vishnu speaking?
yes, sir. My name is
Huh?
Yes, sir.
Vishnu, in that case, if I tell you, are you sitting alone in your room?
Yes, sir. I'm sitting alone in my room.
But if I tell you there are many others around you, can you believe that?
Maybe yes, sir. Because there are so much micro
No need to believe. Can you deny that? That's my question. You may not believe, but can you deny that? No.
No, sir. I didn't deny that.
So can this be a parallel universe?
No, sir. Because we are in one universe. Then how it will be a parallel universe? Because
I will tell you that. Suppose there is a chair in your room. Okay?
okay, sir.
That is an obstacle to us, right?
Yes, sir.
If when I go and touch that particular chair, I cannot move further.
Okay.
Otherwise, I have to take that chair and keep it aside.
Okay, sir.
Suppose there is a creature made of gamma particles in your room. Will that chair be an obstacle to that chair?
No, sir. If it is gamma particle, it can penetrate through the gamma rays can penetrate through. I think the chair. It can penetrate through the
So,
chairs.
if there are certain trees made of gamma particles in your room, or if there are certain huts, certain honeycombs, sort of things made of gamma particles in your room, you cannot see them, right?
Yes, sir.
You can see only those objects which are made out of what you have said, these particles you are made up of. You are made up of certain things like what are they? I don't know. We call them as atoms. Is not it. Atoms can be divided further to some many things, right?
Subatomic. Yes, sir.
But that also is only a belief, right? Because there are many beliefs in the past, and many were proved wrong. And day by day, new theories are coming. And what is the latest theory of atomic particles?
think it was
That is called
azimuthal quantum principle. I think it was the
that
name.
quantum theory. Everything is gone. Now it is called string theory.
But sir,
The latest theory of atoms is called string theory. That is a very purely mathematical theory. And I don't know how many of you have studied or are sure about dimensions. Okay, you may study dimensions in your B.Sc if you go for B.Sc Math. So string theory is a subject which is living in 11 dimensions, a very complicated mathematical disciplines. And string theory says fundamental particles are strings, and strings do vibrate. They can
like a violin string. I heard about that. Like a violin string, there are so much particles. Like a violin string. I heard about in a document.
absolutely, Vishnu. You may just search again in Google. You will find more on that. But unfortunately, people don't like math. And Oxford University, in a recent research, has proved that mathematics is the most difficult discipline. Yes, it is. I don't know the style of proof, but I have read it somewhere that they established that math is the most difficult subject, and that may be the reason people don't like math. Frankly speaking, even I am teaching at NIT Calicut. It is number one institute in Kerala. So my first question to a fresh batch will be, how many among you like mathematics? At least 25% will say, no, I don't like math. So fear is driving them. So just because people don't like mathematics and don't like to do much in mathematics, string theory is still its infant stage and it is not developed further. It is called the theory of everything. And they say, in the sense, those who do research on that particular topic say, even life can be defined if you study string theory properly. So if you study mathematics and physics properly, you can think about doing some research on string theory, and that may even lead to a Nobel Prize. Fine? Okay. Is there any Nobel Prize in math? No, you won't get a Nobel Prize in math. That's why I told you you do some physics also. Fine. Okay. So anyway, I just okay. Coming back to the room business, you can see only things which are composed of or made up of these particles which you are made up of. You think a little about that. But you are not seeing any idea signals or BSNL or Reliance signals which are piercing your head all the time. But there are signals. We believe that. There are signals. We believe that. But we cannot see them. So we are not denying them. So someone please tell me. You should be with me. Otherwise there is no meaning in this one-way chatting. I told you my throat is very bad due to this type of classes and all. I cannot even speak for more than an hour. So don't do that with me, because you must be with me. We have just started somewhere on some corner of this universe. We have to visit everywhere, every discipline, and we will come back to your room later with mathematics, right? Okay, so you should interact. That is very, very important. Okay, otherwise, I may have a tendency to sleep. I may have a tendency to, to go weird. Many, many problems are there. So can someone tell me? Can answer to me? Hello? Hello? Nobody is speaking. That's a big problem to me. Shall I just show my slides and leave them? If you're not interacting, I won't be interacting. I have hundreds of slides. Slide number 1, Earth. Slide number 2, black hole. Slide number, I will go in that way.
Sir, I think infinity is something we can't define. We can't define what we don't know what was that, but we can't define that because how we can define it? Suppose that if it is so much smaller than smaller than everything, and at that time also it is larger than everything.
Frankly speaking, I have already told you in your college when I visited your college, infinity is only a symbol. That symbol simply can be defined like this. Infinity is attached to everything, every human being. My infinity means the place which I have no idea. The concept which I have no idea. For example, you know the sequence 2, 4, then what is that sequence? 2 raised to n. We say limit n goes to infinity, 2 raised to n equal to infinity. Is not it? What's the meaning? There are two meanings. One, I have no idea, sir, where it goes. Second, it goes bigger and bigger. That's another concept. It goes bigger and bigger and bigger and bigger. It goes without any limit. Okay? Infinity means something which is going without any limit. Or in the layman's language, I'm really sorry, sir. I don't know about it. So I simply said infinity. I like the second version. I like the second version. Whenever somebody asks me, sir, what is infinity? I'll say, people, okay, in that way. So infinity is something else. So my concern is how, okay, we are going to explore infinity now. Let me show you another slide and let us explore infinity then. Oh yes, this is one of my previous slides. I don't know where I have presented this. So the title is Infinitely Complex Universe. What a beautiful picture it is. Anyway, I don't know whether it is real or not. Okay, anyway, there is only one thing. You may have little idea about this universe, but I don't know what is your idea. This universe is, I don't know that it will take hours if I start with universe and all. See, I will show you. This is a picture taken from the sky, maybe from some satellite. Okay, you may be living somewhere here. Let us go up further to the universe. Okay, and after many kilometers, you can see Earth in this fashion. Okay, you will see Earth like this. Okay, I don't know, maybe like this. I have not seen it from the space, but I have heard that seeing Earth from the space is a marvelous thing. So we are somewhere here, right? Fine. You go further, but you will see, they are all, okay, stories for us. These are all things which we see on our journey. Okay. They are called Mercury, Venus, Earth, Mars, and all. Okay? And there are beautiful stories about each of them. Each of them, about Mars, about Venus, about Earth, about Mercury. There are plenty of beautiful stories we have heard and studied. Okay? These are beautiful objects. We meet with when we go from this Earth to the space without any limit. On our way, we will find these guys and we'll say hello to them. Okay, let us go. And you know that some of them are very, very big, not like Earth. In this picture, you can see the comparison here. Our Earth, you can see, right? Earth and Jupiter, you may see Earth and Jupiter. And we have studied that there are beautiful rings around Saturn. And there are lakes in Jupiter, you know that. You know many things. Anyway, we don't want to spend much time here, because our time is very, very much limited. Okay? So at the core of so-called solar system, we find this particular guy. It is a star, right? It's a star. It's called a star. And how many stars are there in the sky? How many stars are there in the sky?
Countless.
That means it is in your infinity, fine? Right?
Yes, sir.
Yeah, infinite number of stars. That may be a better usage. Okay. And I'm not going further deep into stars, but there are trillions of billions of trillions of stars in the sky. And we live in a household led by the sun. We live in the house of sun. Isn't it? There are many family members. There are many rooms in this house. There are small sections in the house. There are plenty of people living in this house. Fine. On a clear night, just look into the sky. Okay, what do you see? You will see something like this. Oh, no, you cannot see all of them like this.
Excuse
Anyway,
me, sir.
Eh?
Sir, presenting, sir, it's not visible.
Oh, is it? Why it is not visible? Is it visible now?
No, sir, only your screen it's saying stop presenting, and if you want to stop the mirroring, all such messages are visible.
Just wait. Maybe a problem with my website. Let me check. Actually, I cannot find any problems here. And is the situation is same for everybody?
Yes, sir, we can't see anything. It's only saying that it is sharing something.
I will stop share first. Then I will share it again. What about now?
Yes, we can see, sir. We can see.
Okay, thank you, thank you, thank you. What is this? What is this? You are seeing something here. What is this?
Milky Way.
This is called Milky Way. And anyway, just actually, you may sometimes tell me these are all physics. No, there is no difference at all. But I have to leave from this particular topic quickly. I just want to tell you the size of the universe is infinity, and we are living in a parallel universe. See, suppose we start from Earth on a vehicle. Already there are vehicles started their journeys from Earth to this vast universe. Do you know anybody? Any one of them? No? There are several space shuttles which are moving indefinitely. And there are plenty are there. And not even a single one has crossed the solar system now. Just I want to tell you.
Sir, I think Voyager 1 and Voyager 2 of NASA is crossed.
No. They are still in the Cooper belt on the boundary.
They are crossed heliosphere. I think they are crossed heliosphere.
Yeah, that is the last stage. Actually, at the very end of the solar system, there's a Cooper belt, right?
Yes, sir.
Cooper belt. What are the things there?
I think there are so much asteroids.
Not necessarily ice. Actually, it is far away from the sun, and asteroids only, but they are in the form of ice.
Okay, sir. Okay, sir.
Okay, I think Explorer is there. Anyway, you just look at this. Even this house, this length is 100,000. This 100,000 million stars. Don't worry. Anyway, my question is: see. Entire Milky Way, this is a Milky Way. This is 100,000 light years across. What's meant by light years?
How much distance covered in?
It is a distance covered by light in 1 year. So we are somewhere here. Our solar system is here. The entire length is 10,000 light years. If you travel in the speed of light, if one can live for 100 years in one birth, you need 1,000 births to cover this length. If you can travel in the speed of light, can you travel in the speed of light?
No, sir. Can I ask you one doubt?
Yeah.
Sir, I heard about tin of paradox by Albert Einstein. He said that if you are going the speed of light, you can the time will be decreased.
Yes.
Moving in the speed of light.
Time will not decrease. I'll tell you. That's what Nolan is saying. Have you heard about dilation of time? Time dilation.
Yes, sir. I just go through some physics textbooks, but
I'll tell you that. Just 1 minute. For others, I will explain. We have to get out of this space quickly. All right.
Okay, sir.
Suppose you draw 2 circles. Okay? You draw 2 circles. Whatever is the perimeter of circle, don't worry about it. Myself and yourself, I forgot your name anyway. We are running around the circles. We have stopwatches. Both of us are starting exactly at 10 o'clock. I am running in my own speed. But you are running in a speed of 10 meters per second. Even that speed is not enough for winning a gold medal in Olympics, remember. If you run in a speed of 10 meters per second around a circle there, and I am running in my own speed, a small speed, after some time, at 10:10, according to my watch will show 10:10 and your watch will show 10:09, 59 and something. It will not be 10:10 in your watch. Time is dilated. Remember, time is a relative thing. And it is depending on the speed, the effective speed, you know that. So if you increase your speed, okay, screen problem, I don't, maybe because of network. Fine. What about this screen? Is it fine?
Yes, sir.
Okay. Okay. For time dilation, I have no slides. See, suppose I increase your speed by 10 times. Suppose you run at a speed of 10,000 meters per second. Then your time will dilate further. And it will be something around 10 hours, say 9 minutes, 2 seconds, etc. If you increase it further and if you run in the speed of light, your time will stop. At 10:10, you will be at 10 only and I will be at 10:10. Your time will be stopped. If time stops, what will happen to us? If time stops, in all our holy books like Bible, Gita, old Quran, old Vedants, everywhere it is written that there are three equal things, same thing. I mean, things which are almost the same. Okay? Sthal, Kal, and Bodh. Place, time, and consciousness. Once you lose time, you will never remember where you were today morning. So you lost your consciousness. So if you run at the speed of yeah. Okay. Anyway, I am not sharing my slide. Actually, I am sharing my screen. Don't worry, sir. I am sharing my screen. Don't worry about it. Yes. Now, anyway, let me come back because it's already 12 o'clock. So, anyway, I don't have enough time to speak about. See, our problem is if you learn math, then only you can comprehend physics and related things, remember. See, without learning math properly, you cannot even study anything about space. So what I'm trying to tell you is, you cannot travel in the speed of light. Even if you travel in the speed of light, in future you may sometimes invent some machines going in the speed of light. Oh, don't worry about it. You need 1,000 births with a 100-year span to cover Milky Way. And anyway, I'm not going much. These are not relevant now. Have you heard about Hubble's telescope? Hubble telescope? Yes. Okay. What is that? Where that Hubble telescope is?
It's in outer space.
In the outer space. Why it is in the outer space?
Because due to the light, due to the noise, due to light noises and other noises, they can capture. NASA can capture.
You are right. You are right. Anyway, this Hubble telescope is a mathematical wonder. A mathematical wonder. I will ask you to Google Hubble telescope and study its related things because we don't have enough time for that. It's a mathematical wonder. When I say mathematical wonder, I'll tell you the reasons, but unfortunately I don't have enough time. I will tell you personally if somebody is interested. I told you, if you look at the sky on a shiny night, I mean a good night with moonlight, are you seeing the real picture of the sky? No, you are not seeing the real picture. Why? Have you ever studied so-called Snell's law? Have you studied that when light enters from one medium to another medium, it bends?
Yes, sir. I
Yes,
think it was.
that is why, the environment, the surrounding, the environment around the earth, that atmosphere, so-called atmosphere, is a highly, dense area, density changing from micromillimeter to millimeter. Density is changing. So when light enters from sun, okay, when it comes to earth, it will bend. So on the surface of a lake, suppose you are watching the moon on the surface of a lake or a puddle, okay, even in the water in a bucket, suppose you throw a stone, what will happen? Your vision will not be clear, and it may distracted. You got it? So you are looking the sky through a highly density changing medium. So it will bend. It can create some different effects. Not only that, stars, when you look at the sky, you may see many stars. Those stars may not be alive now, because some stars will take millions of light years so that its light reaches Earth. So suppose one star died millions of years ago, light may be still coming, those things. So this picture which you are seeing now is taken by Hubble telescope. When it was zoomed to a 1x1 window, 1 centimeter by 1 centimeter window, it took this picture. What you're seeing there is a wonderful a mystery. They are all galaxies. The spirals may be galaxies similar to our Milky Way. And this is something similar to a mathematical object called a chaotic dynamical systems. I'll tell you, suppose you just look at the surface of a lake or a small, a river. You can observe different types of phenomena. Sometimes some leaves may be moving in circles, simply rotations. They may be moving in spirals. They may be moving in certain paths sometimes. It will go in one direction, suddenly it will go away. So you can see many, many different types of movements over the surface of such a lake. So they all create certain things similar to this. Little difficult, complicated mathematics. So this is the picture obtained when we look the sky through a 1x1 window. You imagine you take a sphere, you just mark a 1x1 window. When you looked out of that window, you are finding millions of galaxies. So how many galaxies will be there out there? Infinity. So anyway, it will take time for me so that I can tell you the exact size of the universe. Anyway, I think even it's 12 o'clock now. I may not be able to do that, but you will never, that's what is my belief, reach anywhere here. Even this crossing our own home, Milky Way, is difficult. So there are millions and millions and millions of galaxies outside. There may be living creatures outside. There may be different beautiful mechanisms outside. There may be rain outside. There may be beautiful lakes outside. That is what is math. The math is common everywhere. So why we need to study math? The first answer is we need to study this universe. We need to look at the universe with a very clear view. Even though it is impossible for a simple little creature like a human being, human beings are constructed, most of the organs in our body are really bad. Look at your eyes. You cannot even see more than 5% outside your eyes. Only 5% are visible outside you. You are seeing only 5% in front of you. 95% is invisible. Even a dog can see more than you. Your ear is a very bad mathematical, a spiral. There is a cochlea inside your ear, and there is another spiral outside. Both spirals are mathematical instruments. You know that a bat can hear, or even a cat can hear, or a dolphin can hear more signals than you. So most of the instruments or things inside human body are really bad, not at all good. So with this construction, it is not so easy to go and look into this nature, to study these things Okay, everything. So, but we started one by one. We started counting the stars, 1, 2, 3, 4, etc. We did many things. Okay. Anyway, from the sky, I am coming down to the earth now. It's 12 o'clock. So when Neil Armstrong visited moon and came back to earth, there are beautiful things and phenomena in this universe. You know that. I have no time for them now. Okay. Wormholes. So that is what Nolan is speaking about in that movie. Okay. There are wormholes. Suppose you are flying in the sky. Suddenly you are disappearing. You have fallen into a wormhole. Maybe a small one for you. You will be pushing out through the other nozzle of the wormhole at the other end. But you may be millions of light years away. So when you come back to Earth, Earth might have faced millions of years, but you might have faced 1 or 2 seconds in your life. So they are called wormholes. They are available in the sky. Okay, black holes. Only because of black holes we are living. The energy which we are driven are energy obtained from black hole. At the center of every Milky Way, every galaxy, there is a huge black hole that is giving the energy to all these galaxies. And galaxies share its energy to solar light systems. And solar systems gives to these particular individuals. And we, plants, everyone lives with that. It's no time for the time being. Beautiful phenomena outside Earth. So we may, and the galaxies are merging. Our galaxy and nearby Andromeda galaxy will be the same galaxy after certain millions of years. Okay, sun, many beautiful things. I need just this paragraph, this particular statement. I will come back to Earth and I will start with the mathematics after this statement. You may just read this statement. What is this? This statement was made by Neil Armstrong when he came down to Earth. I didn't feel like a giant. I felt very, very small. Okay? So I wanted to tell you that we are nothing in this universe. We don't know what are the energy, what are the things which are driving this universe. We have looked outside. We have idealized objects in nature. And we studied little math. We studied little physics, little biology, and they are nothing. Even a small virus can annihilate us. So there are horrible creatures outside in different forms. We are nothing. We don't know how to measure the length of a leaf. We don't know how to measure the length of a leaf outside. Even if you measure the length of a leaf, it will be erroneous. We will start with that sentence in 5 minutes. I want to stop for 5 minutes. I want to take one glass of water. I will come back to Earth in 5 minutes and we will walk around different locations in Earth. I will emphasize the importance of math and beautiful things which we see around. Okay? Mathematical things which we see around in this nature. And I will tell you what are the possibilities before us. What we can do with this small, okay, as I told you, with this nearness, what all things we can do. What is the importance of mathematics to tackle this particular situation? Okay, I will tell you such things after 5 minutes. It's already 12:05. I will come in 5 minutes. I want to give little, rest to my throat. Okay, don't go anywhere. Go drink some water and come back. Now we will see some beautiful things in this so-called Earth itself, mathematical wonders, right? I think I can motivate you in mathematics with those wonderful things. Okay, I will come back in 2 or 3 minutes. Thank you. Anyway, I'm back. Do you hear me? Hello? Hello? Someone please say yes.
Yes, sir. Yes, sir.
Okay, good. All right. Yes. Can you see something?
Yes, sir. Fractals. I heard about something. Fractals.
All right.
Marlboro set. Marlboro set.
Mandelbrot set. It's beautiful, right? Yeah. Anyway, only 1 or 2 students are responding. Why others are not responding? Better to respond. Okay. You know how this particular object is generated? Anyone knows that?
Any an equation Z is equal.
Correct. Is it equal to?
Hello, sir. Z
Is it
is equal
equal
to Z
to?
plus C. I think Z plus C. Where C Z plus C. Where C is a complex number.
Ah. Then what we have to do? With
Sir,
that complex
then I
number?
don't know.
I will tell you. I will tell
Just
you. Wait.
okay, sir.
I will tell you. Let me ask you one question. Which is the topmost or number 1 mathematical inventions so far, according to your knowledge? Anyone? Even teachers can participate. No problem.
Sir, I think it is differentiation because after differentiation, it came all. I think according to my knowledge, maybe it's differentiation because.
What you are talking about is calculus, right?
Yes, sir.
Calculus is a discipline in mathematics, and I will tell you about calculus very soon. Anyway, your answer is inspiring because calculus changed the face of the world. The entire technology today, you are enjoying good cars, you are enjoying good big mobile phones, you are enjoying internet. You can say calculus has a big role there. I'll come to that. Actually, I'll tell you the biggest invention is E equal to mc square. You know what exactly it is, right? Yeah.
Yes, sir. We can.
What is that? E equal to mc square means you are creating energy, right?
We can. Yes, sir. We can create a physical mass into an energy.
All
We
right,
can
right,
change a
right.
physical mass into an energy.
And that is a stunning invention. You know, it's a mathematical invention because you might have simply heard that physics invention. It is mass and energy. No, there are 11 mathematical principles behind it, and the major one is called theory of invariance. Theory of invariance. There are several forms for that theory. The first version is the, B square minus 4ac. What is the name of B square minus 4ac for a quadratic equation ax square plus bx plus c equals 0?
Discriminant.
Discriminant, right? Right.
Discriminant, yeah.
Discriminant of a quadratic equation cannot be changed by any substitutions. X square plus 2x plus 2 equal to 0 is a quadratic equation. A quadratic equation can be plotted because if you put f of x y equal to f of x equal to x square plus 2x plus c, you may get some curve in R2. I will come to that plane. And when you substitute, anyway, I'm not going to much mathematics, you may put x equal to 2x or x equal to 2x plus 3. You will get a new equation. You find a discriminant again. This discriminant will not be changed. That is the first, law of theory of invariance. Actually, many theories of invariance came after that using this. One of the theory is energy cannot be created nor destroyed. It can be converted from one form to another form. So it is simply an algebraic invention. And after Hiroshima and Nagasaki, European people were thinking to stop teaching mathematics in their schools. Anyway, for the time being, I'm not interested to speak about E equal to MC square because that is a marvelous thing. And we need more time on that. We need more time. That equation says if I take 1 kilogram flesh of my body and convert it into energy, all fans and light in entire India will run for a full year, 1 year. That is what is the strength of that equation. So that is the number one invention. Actually, there are plenty of beautiful mathematical inventions like operations research, several things in operations research indeed. As you said, this particular theory of calculus, many beautiful things. I'll just tell you a story. The problem is time. There are plenty of beautiful stories about calculus. Have you ever heard about a problem called Brachistochrone problem? If not, you may just Google Brachistochrone problem. I told you just 10 minutes back, when light coming from sun to earth enters in the earth's atmosphere, it bends. And it will be taking a very specific path. That path is called a cycloid. Cycloid is a mathematical curve called Helen of geometry with beautiful properties. When a rabbit jumps, the rabbit is automatically taking a cycloid because there are several advantages. I think I have certain pictures, but I don't have enough time for that. And when a chameleon simply keeps its tail in a particular shape, it may take the shape of a chameleon. Anyway, a cycloid. Then kangaroos jumps our cycloid to minimize energy. When sun sends a ray of light into air, its intention is to minimize the time and hence minimize the energy. So there are plenty of such. The cycloid is one of the very famous mathematician called Bernoulli. There are several Bernoullis. Bernoulli said this is a marvelous spiral. I need time for that. I will come to that soon. Anyway, let me speak something about these fractals now. Anyway, let us see a beautiful video. This particular picture is obtained by iteration. Z equal to something like Z square plus C with a constant C. You put some Z value in the beginning, say 0. You will get an output. Okay. You give that output as input. You will get another output. Again, give this output to input. So you may get something like 0.1, 0.10, 1.001, 0.0001, etc. That sequence will be converging to 0. If you put 2, Z equal 2 plus I, then 4 plus I square, it goes in that fashion. It diverges to infinity. Okay. So you plot all the points which are converging to 0. You will get this black portion. And points which moves infinity in a moderate speed are this white portion. The points which move to infinity in a very much large speed, this blue portion. Let us see a simple portion. This is a mathematical invention of the 20th century. This is said to be the second highest mathematical invention ever. This is called Mandelbrot set. I will show you some simple videos. Can you see this video?
Yes, sir.
Yes, sir.
Yes, sir.
I'm going to the boundary of Mandelbrot set. You can see all varieties of patterns, even those you see in your dreams on the surface, on the boundary of this curve. There are lakes, there are trees, there are humans, there are animals, there are mountains, everything is there. In YouTube, there are hundreds of videos. You may download some videos and you can watch it. Okay? And, you know, when you zoom in, you can see the same object inside. Okay? You can see the same object inside. Look at this. What is this? Can you see this? Please say yes.
Yes, sir.
Yes, sir.
What is this? Is called a broccoli, right? Yeah, it's a broccoli. When you zoom this broccoli, you will get almost similar structures, right? You take a smaller portion again and zoom, you may get the same thing. When you have that Mandelbrot set, when you zoom inside, you may find the same set inside. This is called self-similarity of nature. This is called self-similarity of nature. This is something like a cancer growth. That's a growth. Okay. Look at this. This is the picture of a lake from Finland. You can see there is something called self-similarity. Look at these clouds. There is a self-similarity. Look at this small plant. There is a self-similarity in the sense. You take a small portion and zoom. It will look like the bigger one. Then again you take a smaller portion from there. Zoom. It will look like the bigger one. This property is called self-similarity. Okay? Look at this. Self-similarity. Can you see self-similarity? You may just take a cut of this anywhere and zoom it out. It may resemble like the original tree. Yeah? That is a property. Anyway, what we are talking about are natural objects. I am starting with another question now. Question is, why we learn mathematics? I am not going to spend much time. The answer is, I want to know more about these trees. I want to measure the length of a leaf. I want to know what is there in this nature. I want to learn nature. To learn nature, we want to study mathematics. That is the question. Many thousands of years ago, when Euclid observed this nature, he also found these trees. He also found cones. He also found mountains, many things. But he couldn't write the proper math that time. What he wrote is, he idealized objects. He drew a cylinder looking at the trunk of a tree. He started to draw a cone looking at a mountain. He started to draw a circle looking at the sun. But sun and a mountain, is it really in the shape of a cone? Answer is no. Okay? A tree trunk, is it indeed a cylinder? Answer is no. So, in mathematics, so far you have studied many curves, right? Can you give me an example of a curve in mathematics? Not necessarily in mathematics, anywhere in science is okay. Parabola is a curve, right?
Circles in
Circle is a curve. Parabola is a curve. Can you find a parabola in your own body? Just take the cross section of your eye. It's a parabola. This particular plate is a parabolic plate. You know, you have seen these radars and dish antennas in your house. They're all parabolic. How many, have you studied about parabola before? No. You might have studied parabola, right? How many focus it has? No idea. There is only one focus for a parabola. Have you observed this mist lights of a vehicle? Snow lights of a vehicle? They are similar to our eyes. This portion of pupil actually. It is similar to a radar. Whatever is coming to radar from the inner side will get reflected and will pass through its focus. That focus is the position where we have, in our dish antennas, there is a position where we have a mug, a cup, small cup. We protect that small portion because that is the booster of the dish antenna. Whatever signal is coming from the satellite will reflect at the surface of this dish antenna and will move to the booster. Booster will get many signals by principle of superposition of waves. One by one, that signal will get strengthened and you can see a beautiful picture in your television. In the earlier times, now technology is changed. So that's an application of parabola. Parabola is a mathematical curve. You know that y equal to x square. Now, most of you might have studied calculus, right? In calculus, we talk about differentiation. We talk about differentiation and integration. When we say that a curve is differentiable at a point, look at this. There are plenty of things, not necessarily. Look at this triangle. There are 3 points where tangents bends sharply. Can you see this triangle? One is this point, and there is this point, and there is this point. At these 3 points, the curve is not differentiable. At those 3 points, the curve is not differentiable. Okay? So what about a circle? Is it a differentiable curve? A circle? A circle is it differentiable at all points? You know the definition of derivative? Hello? Hello, can you hear me?
Yes, sir.
Yes, sir.
You might have studied differentiation, right?
Yes, sir.
Is this particular curve is differentiable at these 3 vertices?
No.
Why?
No.
Tangent is perpendicular to the x-axis.
Or tangent is not unique at these 2 points, 3 points?
Yes, sir.
Okay. Anyway, for a circle, so what about a rectangle? How many points of non-differentiability there?
4.
What about this? The second curve? So many are there, right? So many are there, right? Yes. For this curve, number of non-differentiable points is more than this. This more than this. This more than this. So that is what is calculus, right? Let us visit a honeycomb now. You might have seen this, right? Yes?
It's hexagon shape.
Can someone tell me why honeybees, well, maybe, we don't know, why honeybees construct their houses in these beautiful shapes? Any idea? During summer, okay, this is not needed now. These are not needed now. If time permits, we will come to such things. Yeah, I think I'll take this. What are the shapes seen here? Parallelograms, right? These parallelograms are rectangles, right? Using these rectangles, you can tile any room. This shape is a space filling curve. Okay? Of course, a square is again a space filling curve, right? What about a triangle? Is it space filling? Yes, you can see from this picture that it is filling. There are no gaps in between. It's a space filling curve. What about this? What is this shape? Hexagon. Is it space filling? Yes.
Yes.
So far, so good. What about this? What is the shape?
Pentagon.
Pentagon.
Is it space filling?
No.
So we have seen triangle, rectangles, pentagons, hexagons. But next maybe with the 7 sides. Next maybe with 8 sides and all. This one, how many sides? 7 sides. Is it space filling? No. No means you can find certain gaps in the middle, right? Yes. Okay. Number, I will tell you one beautiful thing now because I may not get enough time today. So I'm giving you a glimpse now. 2010, Nobel Prize in Chemistry. That was for a beautiful invention called golden crystals. Okay? One chemistry man called Deshman. That was here. Not available. Invented a new type of crystals. Generally, chemistry people or crystallography people believe that only this type of crystals are available. This type means if there is a square in the face of a crystal, it is called a cube. If there is a rectangle, tetrahedron, and so on. So look at the symmetry. This pentagon has 5-fold symmetry. The others do not have this 5-fold symmetry. Chemistry people believe that 5-fold symmetry is not allowed in crystallography. Okay? And these are crystals, tetrahedrons, cubes, only these 4 cubes, tetrahedron, and this space filling curves. I have already told you about space filling curves. This Dutchman showed that 5-fold symmetry also is possible in crystallography, and that is why he invented beautiful, remarkable metals with interesting properties. If you plate those metals in certain type of pots and vessels, we have advantages. In frying pan and also this type of crystal coating is used so that it won't come out. Anyway, I'm not going to that area now. So I want something else. So 2000 chemistry Nobel Prize was based on the topic which we are going to discuss now. And inspiration is no one else, honeybee. Honeybee is the inspiration. So why honeybee selected this hexagons? I told you the first reason. What is that? Somebody tell me. Because
Space filling.
Space fillingness. Because suppose they use circles to construct this in circular form, what will happen? There may be space in the middle. Someone else can come and live there. Okay? It will fine. Frankly speaking, these honeybees know mathematics better than us. Because several mathematical disciplines and physics disciplines and chemistry disciplines are incorporated in the construction of honeybee combs. Geometry is visible. So, space fillingness, it is fine. Now, I told you about differentiation. Consider a rectangle, a triangle, a hexagon. Okay, they are the only space filling things. Circle is not allowed, pentagon is not allowed. So honeybees didn't consider anything else. Just they considered a triangle, a rectangle. Rectangle has several shapes. It can be a square, it can be a parallelogram, whatever it is. So a rectangle, a triangle, and a hexagon. Out of which, suppose you are asked to construct 3 small rooms, either of these 3 shapes, where you have to live comfortably. Which one you will select? A triangular shape, or a rectangle shape, or a hexagon shape? Someone tell me. Which one you will choose?
Rectangle.
Huh?
Rectangle.
Why?
Simple construction.
But the problem is construction is simple, but room is very small. So you may
Yeah.
have problems at the corners. Even you may not be able to sleep well in the room. If more in, derivatives moves, tangents move less quickly in a rectangle than a triangle, and lesser quickly in a hexagon. So in a hexagon, you can move, these rooms are very, very small, remember. You imagine triangles in place of hexagons. What will happen? A small baby of a honeybee cannot even, I'll show you one picture. I think it is available. No, it is not available. Let me try. I have a small problem with my throat. Don't worry about it. So I will be. So look at this. You can see small babies sleeping inside. These small rooms. If it is in the shape of a triangle, it may be difficult. So they considered all the three. They calculated the level of smoothness. Differentiability means smoothness, and concluded that among all the space filling curves, hexagon has more smoothness. You know that a circle will have more smoothness, but that cannot be used. Why? Because circle is not space filling. There is one more huge advantage. That is, that is coming from the subject called operations research. In mathematics, there is a subject called operations research. I told you an interesting story. My throat is very bad even now, but still I will try to tell you the story. In Second World War, Germany was, really moved behind. Hitler invited all scientists and mathematicians and asked them, we don't have enough food, we don't have enough arms and ammunition, we don't have enough men, but you have to find a solution quickly for these problems. Otherwise, I will kill all of you. So these scientists tried very hard under these circumstances, and they developed a theory to survive with this. That is called, it is like Operations Blue Star. It is called Operations Research. It contains several portions: reliability theory, how reliable a component of a warfare is; elementary, then queuing theory, which we use in computer systems, internet, and mobile systems nowadays. Sometimes when you make a telephone call, they will say you are in queue. We use that math problems. So in 2 months' time, scientists worked very hard and they found solution to these problems, And in operation research, there is a theory called optimization techniques. There is an optimization here. Can somebody tell me what's an optimization here? I would like to ask you. I tell you one thing. After the class, we just Google honeycomb conjecture. Honeycomb conjecture. You just search honeycomb conjecture. So honeycomb conjecture says, if you have a fixed amount of wax and you go for constructing nets of this type with circles, with triangles, with rectangles, and this will be having, if you have a fixed volume, this will have a more surface area. If you have a fixed volume, it will have a more surface area. The surface area is a big thing. Anyway, I wanted to tell you something about surface area, but I don't know whether I will get time. I told you about fractals. This is also a fractal. This is also a fractal. And after this, I will go to something related with the fractals. Now, if you make 6 hexagon, look at this. 1, 2, 3, 4, 5, and 6. One hexagon is free. 1, 2, 3, 4, 5, 6. So that is an optimization problem with the time and wax for 6 seconds. We can make 7 hexagons. So that is another theory. Now, another very important theory is coming from elasticity theory. Suppose you make this house in a rectangular patch. Okay? You just kick to this honeycomb. That may break. But this is hexagon. Hexagon has more ability to spread the stress coming out from a point. Even if you kick at the bottom, that force will spread automatically to everywhere and nothing will happen to this honeycomb. Okay? So I wanted to tell you, honeybees know better maths than us. So mathematics is a tendency. It is not a subject invented by human beings. It was there. We didn't invent anything. That's the truth. Now, let us go back to this earth again. Let us go back to, anyway, there are some beautiful things related with honeycombs and galaxies. If I have time, I will tell you about those things. They are called golden ratios, Fibonacci numbers, etc. But we don't have much time. That's why we'll go to something else. Again to these leaves. Okay. This is a sentence by famous mathematician Benoit Mandelbrot, the mathematician who invented that fractals. Okay. He made a statement of this type. Clouds are not spheres. Mountains are not cones. Coastline are not circles. And bank is not smooth. He is right? He is absolutely right. What he observed is that I already asked you about this. Initially, I told you Euclid idealized objects found in nature. Is there any straight line in this nature? Is there anything straight in this nature? Answer is no. There is nothing straight in this nature. Okay, because of our eyes problems, it may seem like a straight line. You just look at that with a microscope. You can see it is like a mountain. So nobody can draw a straight line. They are not straight, but relatively for a human being, it seems to be straight. Is there any cones in nature? No cones, no circles, no sphere, nothing. That is what is Mandelbrot mentioned. And I told you, you cannot even measure the length of a leaf. Okay. Let us look at a leaf. I think I have a leaf here. No. You may be bored, I know that. My throat also is very bad. I will stop in 10 minutes. All right, look at this leaf. You might have seen leaves like this. Can anybody from this group measure the length of this particular leaf? In my childhood days, we used to take such a leaf and make an impression of the leaf on our wrists. We'll keep this leaf on our wrist and do like this. So the impression in white color, okay, like a tattoo will appear on our wrists. You might have seen that. This is a beautiful leaf. Look at this. This is a self-similar leaf. The entire leaf is similar to one of the portions. This portion is similar to a smaller portion. You can further go down.
Sir?
Yes?
Is it golden ratio, no?
No. We have not discussed about golden ratios till now.
Sir, it's a sir, is it a fractal? Because if it is self-similar, is it a fractal?
Actually, it is not a real image. The image you are seeing is not at all a real image. It is mathematically generated. This is a mathematical.
Sir, because when I was in college, my professor is doing in his MATLAB when he created this in MATLAB.
Exactly. It
So
is also created in MATLAB. So, actually, using our old geometry, you cannot create this. We need a fractal geometry to create this type of natural things.
sir, can I
Yeah,
ask one thing, sir? Sir, you said that fractals are in everywhere in nature.
yeah.
Then how do you find how if suppose that if a object was fractal, how do we can find that? Is any dimension or like that? Because if you are using in a any other for if you are using suppose that you are using in a deep learning or deep learning technique, so how will you find that if it is a fractal or not? Is any type of a dimension or any type of a identification method to find a fractal, is it a fractal or not?
Anyway, I assume that you have the knowledge in fractal geometry. Okay, I will answer to your question in 5 minutes. Okay, wait for a minute. So what I am trying to tell you is, using our old geometries like those you have studied in your high school, there is a name to that geometry. It is called Euclidean geometry. But that period of time, that was a necessity because there were no other mathematical tools. Even today, look around. Your wall is in the shape of a rectangle. Your ceiling is a rectangle. Your fan is a circle. Light a square, a cylinder. Classical geometrical objects are used in our rooms. But in nature, there are no classical objects. Look at a honeycomb. When outside temperature is 47 degrees, honeycomb will automatically adjust its temperature and an interior temperature will become automatically 22 degrees. How? Because there is a natural geometry involved there. It's not human-made geometry. So in human geometry, this natural effect cannot be brought. We cannot construct a room whose temperature inside is 22 degree always, irrespective of outside temperature. Why? Because we do approximate. We hope that in future it may be possible. Now, two things needed: intelligent machines and one intelligent mathematics. So anyway, let me come back and tell you one thing. Can you measure the length of this leaf? Never. If I ask you, I can pluck out a leaf from the tree and I can give it to you. If I ask you to measure the length of the leaf, you will take a small scale and you will measure it and tell me, sir, 25 centimeters. But is that 25 centimeters correct? Never. Because I will tell you the mistake you have committed. Not with this tree example, with another example. Anyway, I'm mixing so many topics, so that is why, don't worry about it. My intention is just to give some glimpses, that's all. I will tell you why with this lake example. If we ask you to measure the length of the lake, you will come with a 1 meter scale and will measure it as 1, 2, 3, 4, 5, 6, 7, 8. You will tell me 300 meters, sir. But next day morning, Arya will come with a 1 centimeter scale so that she can measure more crooks and bends. And she will say 500 meters, sir. Next day morning, I will come with a 1 nanometer scale so that I can zoom these portions. I can measure all the crooks and bends. I will tell you 2000 kilometers, sir. Next day morning, one comes with a high power microscope and measures it and say 20,000 kilometers, sir. As we reduce the measuring device, the length is getting increased. Limit, measuring scale goes to 0. Length of the lake is infinity. That is what his mathematics teacher taught us. Because 2, 4, 6, 8, that's a sequence which is diverging. It goes to infinity. So that means I cannot measure the length of this particular boundary of the lake. In a similar manner, you cannot measure any boundary, even that of a leaf. So we are human beings, not even capable of measuring a leaf. Whatever mathematics we have developed is not at all enough to measure the length of a leaf. Now I'm coming to an interesting observation from the nature. So none of the curves in mathematics are smooth. None of the curves in nature, not in mathematics. In mathematics, a parabola is a smooth curve, circle is a smooth curve. Suppose we draw a curve here, but that will be looking like some blah 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 blah. Where is that? I will show you something. Such curves are called nowhere differentiable curves. I don't know whether you people are aware about nowhere differentiability. Look at this. I will give an example. It's a triangle. You remove the interior triangle. It is very easy. Plot 1 point here, plot 1 point here, plot 1 point here. Remove the interior part. Do the same business with others also. Now, only we have these black objects. White is gone. So how many irregular or unsmooth points are there? 1, 2, 3, 4, 5, 6 points. Now, so many points included. Now, many other points. Now, many other points. In that way, if you continue, you will land with something called a fractal. This fractal is nowhere differentiable. I don't know how we'll tell you. See, this point. There are 3 points where there is no derivative exists. You repeat this process. You replace all these individual small line portions with the same picture. You will get this. Okay? Such a process is called an iterative process. You are getting more points which are not differentiable. Do the same business, more points which are not differentiable. Finally, you will land up with such an object which is nowhere differentiable. So that is the major difference between a curve in nature and curve in mathematics. In mathematics, most of the curve are differentiable. Mathematics, when I say mathematics, the geometry which we have studied before. So what we want to study this natural geometry. Then only you can define nature, define natural phenomena, define and generate mathematical objects. It goes in that way. Okay? So fractals are all around. Whatever you see are fractals in this nature. I think tomorrow, you have Rajan sir from Aisha. He's an expert in fractals. He may be talking more about fractals. Fractals are beautiful things seen in this nature. Okay, so the geometry is changed first of all. You know, in order to study fractal geometry, whatever mathematics we have developed so far is not enough. Okay, then somebody asked me about how we can realize that it's a fractal. Whatever you see outside is a fractal. Anyway, in order to study them properly, we have only limited resources. Our tools are called real analysis, complex analysis, measure theory, algebra, differential equations, number theory, numerical analysis, probability theory, quantum theory, stochastic process. Then these are the tools. Calculus, they are different mathematical disciplines. All these tools are used in the study of fractals. So it comes as the answer to my question. Why we need to study mathematics? We need to study nature. We need to measure the length of a leaf. What we want? We want all mathematics. That is only a portion of what is required. We need multitudes of math. I told you, you cannot study life because you don't know mathematics. That string theory is in its childhood stage only. Similarly, fractal geometry is difficult because it involves all math and physics, all subjects. So we need to work more and more. Then only we can explore this universe. Okay, universe is a beautiful thing. You know, it is abundant of what we say, fractals. See, fractals everywhere. These flowers are fractals. Anyway, today I don't have enough time to speak about this. Okay, I will show you more and more beautiful fractals. These flowers are fractals. Okay, and they are all related with something called the golden ratio. Why nature prefers fractals? answer is not given to you. You will find it out yourself if you are interested in math in future. Music is a fractal. Music is a fractal. Then I'll go. I'm not going to give you any theory here because time is already 1 o'clock. My throat is very, very bad now, like anything. Very bad throat. See, these are all fractals. You can see spirals here. This is a natural spiral. You can see self-similarity. Look inside. Same pattern is coming inside this. This is one of the prime properties of fractals. So this is a fractal. What is coming here is a storm. It's a fractal. It's a huge fractal. This is a fractal. It's a roll. It's a natural object, a beautiful spiral. This spiral is called spira mirabile or logarithmic spiral. I need words to speak about this. It's a beautiful object. This spiral is a natural one. I told you chameleons used to keep their tails in this fashion to minimize the energy. These are human-made, spirals. Spirals are fractals indeed. I don't have enough time to explain those things. We have to construct such beautiful things. It's a human-made spiral of many, many properties. You may ask, you can please visit Google and understand what exactly it is. These are galaxies. Even galaxies obey these mathematical principles. Fractal geometry is there everywhere, even in galaxies. So entire nature obeys fractal geometry and mathematical disciplines. So deal with these type of natural things. We need math. You have to study math. There are beautiful, interesting things. I will show you one more interesting thing to end up this presentation. Most of the mechanisms, like hearing mechanisms, eye-seeing mechanism, are all related with mathematics and mathematical things. This ear is working on the principles of resonance. I'll show you one very nice resonance video.
As you can see, this bridge was exceptionally long and narrow.
I'll show you. This is a bridge in. This was a bridge in United States, built over a river called Tacoma River. A beautiful bridge. You may find this video in YouTube. There was wind coming
on November 7th,
from the
suddenly went into a twisting
ocean.
motion. The wind speed was a steady 42 miles per hour. This was enough to keep the bridge oscillating in one of its natural modes of vibration with a period of 5 seconds. A professor of engineering went out to see what had happened. He's coming back, walking with some difficulty along the nodal line, which is the center stripe of the roadway. It's remarkable that the girders were this flexible. This is photographed at normal speed. However, a collapse was inevitable after a little more than an hour of this.
You know what happened after some time is?
Bridge.
Bridge collapsed in the river. Okay? So, this is how our ear works. Ear works with the principle of resonance and mathematical ideas like the spiral which I have shown to you. The spiral which I have shown to you is inside your ears. It's a cochlea. And there are many vibrating tails inside this cochlea. Anyway, the only problem is it will take time to explain to you. If someone is interested, of course, I can tell you how it works. What I am trying to tell you and what I am trying to conclude now is everything in this universe depends on mathematics and works on the principles of mathematics. Unless you study math, you cannot even study physics. Math, physics, and all other scientific disciplines are one and the same, provided the underlying language is mathematics. If you study mathematics properly, nothing else is difficult. Okay? So you have to study math, you have to enjoy math, understanding the applications, understanding the beauty, and understanding the relevance. I don't know how much I was able to deliver to you today. The latest half, I was growling like anything because my throat also looks very bad. I'm going to wind up here now. I have plenty of things to tell you later in another class. So we'll see that time. So I'm going to stop now. If you have questions, you can ask me now.
Sir, sir, this is small doubt. Can we, if we can identify the fractals, then you said that everything is in nature is fractal. So if we can identify the fractal and you said that you draw a phone like a structure, and I see that phone like a structure in my browser also. But if we can create something with equations, we can avoid pictures. Can we avoid pictures, and we can use the storage for if you write a simple equation that can produce this type of images. Can we remove images? Can we remove images and use fractals to
dimensions that will tell you how crooked and complicated a fractal is. There are simple fractals and complicated fractals. It depends. So fractals are defined based on certain characteristics. If one of the characters there, we can call it as a fractal. And another thing, fractal will change the world one day. Today, we are struggling to download data, struggling to upload data, even uploading 100 image of a picture of 100 image or a video 100 GB will take days. In future, it won't be a problem because fractals will help you. Fractal transforms will help you. I don't know how much you will digest this. One thing you remember, fractals will change the world in future. Your images, your videos, everything will be stunning. You can send beautiful things quickly. And communication theory, everything will be changed in future because of this invention of fractal geometry. And studying fractal is a very difficult task. Identification, you told me about producing fractals. Yes, that's called a iterative function system. Using a set of equations and a hi-fi computer, you can produce any image in this universe without any difference at all. A tree, but using circles and triangles, you cannot draw a tree. But using fractals, you can produce anything in this object. After 20 years, there is no need to shoot a movie. Everything can be made in a computer. No actors needed, only an actor face is needed. That actor will be acting without actual acting. So many things we may have to witness in future because of this invention. Many. Okay? Right. Any picture can be generated using a system of equations. Natural pictures. Any other questions? All right, if you have questions, you can email your questions to me. It is already lunch time, so I am going to wind up here. So thank you very much. If you have something else, you can ask me.
Sir, how to study fractals? Simple question.
Pardon?
How to study fractals? How do we study fractals?
What is your background? Are you a degree student or a
Hello?
Are you a +1, +2 student or a degree student?
Sir, I'm working in a cloud-based company. We are using deep learning for everything. So we are using so much mathematics, but I'm a mathematics student, but I can't understand so much of the mathematics. So they are using different type of tools. They are using deep learning for solving the problems, solving complex problems. They are using machine learning, like linear algebra and machine learning. They are using like that. So I heard about fractals. I heard about fractals, but they are using box counting technique. They don't know how to. We don't know how to set the fractal. We are using box count.
I have a request to you. Actually, what you are saying are all above the, scope of this, particular audience. Because you just write to me or ask me, I will tell you what to do. You can just personally call me or you can write an email to me. I will explain things, what you have to do. But if I tell me something here that may not be digestible to the remaining audience, so you may just contact me directly. Okay, right? I will help you.
Can you please give your number? Can you please share your numbers? I don't know how in your number.
You just search NITC website. You will get my email. You may just send an email to me. NIT CALICUT website. Go to mathematics department. You may find my name there, and email also is available there. You may just email it to me. Okay. Right.
Okay, thank you very much, sir, for your wonderful talk. Hope that it was very beneficial for our B.Sc aspirants and also other people. So thank you very much.
You're welcome. Anyway, today my throat.
Webinar.
There was some problem with my throat. That's why second portion was a little bit slow. Don't worry about it. I hope you understood little bit. That's enough. If you have motivated little, that is enough. You may just use Google and find many interesting things from there. Thank you. Have a nice day.
Thank you, sir, and thank you all the participants. Bye.